Hello, my name is Alexandre. I'm a data scientist at Intel Security, and today I'm going to present bridges to JavaScript and Python in Go. All of that is going to be coded live, and that's Emacs that you see here. You'll see it's one of the, and Poirot is the name of my machine. Okay. Oh man. Phew. Oh shoot. So let's start. The first thing I want to talk about is Auto. Auto is a library. Auto actually is a JavaScript VM. It's an ECMAScript 5.1 interpreter, all written in Go for your pleasure. So that would basically be something like V8. It does not have all the optimization of V8, but it allows you to bring a JavaScript VM into your Go code, have it cross-compiled, and work anywhere. So you can easily, for example, have scripts that are interpreted, whereas your Go code is all compiled. So we're going to try that out here. And we can get Auto with going here, word creamin Auto. And this will also install, very fast, huh? The Auto executable, which is like Node here, right? You run Node, and you type in some commands. So let's say var hello, and then so some math, something like that, right? And then hello, some math, and then Control D here, and it interpreted JavaScript. So you can, like, full ECMAScript 5.1 is supported there. You can have classes and stuff. And but what is cool is to be able to put that in your own program. So let's create a little code in JSVM. And we'll make that package main with a little function in which we are. Whoa, there's no color syntax. Whoa. I don't have my Go mode. That's crazy. You guys will need to bear with me. Oh, scared me. Okay, there we go. So, and over here, we're going to just create an Auto VM. Right? That'll bring in Rickman's thing. Yeah, I have a lot of packages installed, so sometimes it's slow. Go imports. And what we can do in there is we could execute some code with VM run, like console log, right? And hello world 1 + 2 + 3, right? And then close this and close that one. And if we run that, let's go in JSVM and go run main. Okay, we have it. So this runs and executes JavaScript inside my code, which is exciting, right? So how do you interact? We can add inside some global variables. Let's say var, value 1, and over here, see set. Down there, you see the syntax for that function. Takes an interface, and that'll be 1, 2, 3, and then val2, I don't know, 4, 5, 6. And in there, we can use the multi-line strings here. We can do some computation. So var val3 would be val1 plus val2, and then we'd print, I don't know, let's print hello world. We keep that in here. Oops. And let's say ret equals, I'm lost. Okay, and then we need to verify errors. Obviously, each time you write some code like and you don't verify your errors, you're bound to fail. Over here, we'll make sure we handle the errors, and we're in run. All right? And if everything works fine, output. So out here. Does that make sense? What? Oh, man. No, not yet. Okay, let's just see if it runs. Takes a little while to compile, and output is undefined because we don't have any return statement. That's not what we're doing here. If we want to have var3, then we interact with the VM, and we go extract that value. So we say get val3, and that here returns a value. So val3 and an error, because it's possible that this fails if nothing is defined. And then val3 is a value. So val3 here is defined there. And it returns a value. The value in the auto libraries, notice up here, those are the packages. So the files, you have great tooling in Emacs. And then if we define, these are all the, this is using Guru or the Go Oracle to find out in the code all the methods attached here. So we can call is primitive as an object and all these things. And there's a to integer. Let's use that, right? Main val to integer, and that returns two things. Return value. Here again, we can have errors. Always check your errors. You want to run the talk once, get 3 errors. And you're going, oh, what happened? You don't check your errors. To integer error. Okay, and then we can print return val. How's that? You think that'll work? Ah. Okay, we aren't using that one anymore. True. Okay, cool. So what we have here is the computation of that, and you're interacting with the VM, get value ins, values out. You can dynamically run scripts that you pass as a parameter, but run also takes a script. So you can pre-parse the script, have it in a script object, and run here takes an interface. If it's a string, it'll do the interpretation. See, it's an interface. And if you have a script, it'll just run the pre-parsed. AST is already done, and you can execute the code. So that's auto. Now, there's another thing that's really cool. Oh, yeah, just so you know, over here you might see it takes a little bit of time, and maybe asking for performance. If you build that, and you have JSVM, it's built, then it's really fast, right? It's not that it was the time to compile the whole thing, and the whole JavaScript interpreter, right? Compiling V8, I think, takes a little bit more time. Okay, let me now jump to Gopher.js. And now you'll be blown away. Gopher.js is a Go to JavaScript transpiler or compiler. And its aim is to be a target as generic as AMD64, ARM, or other platforms for Go. But it compiles everything into pure JavaScript, which you can run in Node, and you can run in the browser. With the whole awesome features you have in Go. So Go routines, channels, blocking, non-blocking stuff, it's all in your browser. Let's try that, right? How exciting. So we start by installing it. And so go get Gopher.js. And that, oh, you know what? Yeah, let's just switch. I think I have the version for Go 1.6. Perfect. So we have Gopher.js, which is a binary. And we can build stuff. So I'm going to go here. And we're going to create Gopher.js code.go. OK, mind you, this is Go code, right? Has a main function. And what we can do is call alert with some, like, we're good. How's that? Just fetching and Go imports, thank you. OK, this brings it the JS package. And if we run that, first of all, Gopher.js build. Oh, yeah. Will that work? See how fast that was? And then we get that Gopher.js.js. This is our program. Go. Transpiled to JavaScript. Everything is managed. You have Go routines in there. And look, you can do Gopher.js serve. Let's try that. They're laughing. That's crazy, man. It's an awesome piece of work. So let's say we go here, Gopher.js, and then this is interpreted directly in your browser. So what we see here is that that's Gopher.js serve, right? It's just putting your JS code in the script tag. It's not even in the body, so body doesn't exist there. but if you run it, it runs. Okay, now let's try something more exciting. If we go in here and we try to get something, there's a website that allows you to test your cross-origin features or stuff. Let's check errors. And you can introduce error in get. What is that? Println. Raise your hand if you knew the special feature. You didn't know. Yeah, it's a special feature inside Gopher.js. So don't use that if you want to cross-compile to other platforms. So Gopher.js will know that this becomes a console log. And over here, we're going to load HTTP. And the awesome thing is that Gopher.js has all of the standard library. Almost all. Some things that are not available, that don't make sense, like OS open file and such like that, won't be available. But all the rest, if you're in Node, those will be ported. And there's a like JavaScript implementation of the standard library for most part. Other things are just taken plainly as Go code and transpiled to JavaScript. So only things that need to be reworked in the browser are. And let's load the content here. Util read all for the rest of the body. And why not use the sweet features like to close that after, right? And we'll copy that. Error in read all. Does that make sense? And now what we can do, so output content mapped to a string. Otherwise, it would be a series of bytes. How does that look? You think that'll work? You don't know. So Gopher.js is running, and we just refresh here. And let's try that. So we're good. We got the output here, and we got the call, the cross-origins test. Wow, look at that. We have Go, because we have source maps. Yeah, why not? So you can debug your Go code directly here. That's neat, right? Okay, so let's try to make that one fail. Let's try to go to example.com. Will that work? What? Oh. So it's recompiling the whole thing, and then, so we're not allowed cross-origin. We get error in get, that's printed out, and we happen to have an object. All of that is kind of serialized. Do. That's the format you have internally for Go errors, right? When you call ERR, that's what you have. So that's and let's take a look here again. If we do that now, look at Gopher.js boosted a little bit. It's 4 megabytes now, because now you need a lot more. You need Unicode stuff, all the HTTP stuff, all the dial functions, and many things to deal also with concurrency, because there's channels that are established when you do some HTTP requests and some pooling and stuff. So that's still not bad to be able to code Go in the browser. Yeah, in the browser. Okay, and let's try something that interacts with a very simple thing to interact with the DOM. Because after all, like JavaScript or the browser is about the DOM, right? So what we can do is get document and then get the body. And then we're going to set inner HTML. You see that here? And Gopher. Where's Gopher? Ah, it was a trick. So I grabbed that from some URL there. Okay, so if we set that, what do you think that will do? What? Raise your hand. Say something. What do you think that will do? Load an SVG. Oh, of course, I wasn't serving. Woohoo! So that's Gopher.js. Okay, now, okay, one last thing that makes the whole thing very funny. Okay, you tell me what this does. And then we load that with Go imports. Okay, let's build it. They're laughing. That's amazing. So we have 7 megabytes now. What is in there? No, that's the full interpreter. So what happens if you load this? Of course, serve. So what we see here, down the little, you see that? Woohoo. See that, right? So this is code that ran. We wrote it in Go, right? But it was actually JavaScript because it was inside the JVM there, God forbid JVM. And then it was transpiled to JavaScript, right? To be able to be running in the browser. Yet it's JavaScript running in the auto, right? Running in the browser. See, that's the power you bring. You have the whole, it compiles very fast. You have a full-blown JavaScript interpreter. Imagine what you could do. You could run, I don't know, Ruby or Perl or some other stuff in your browser, and that is all portable. You can bring that and run it on all your devices, your Android, ARM, iOS, a host of other platforms. You might have noticed I've cut that talk. It was too long otherwise, going through Go Mobile. Sorry, another time maybe. Okay, is that exciting? Okay, so maybe you guys think, this is stupid. Because we already have perfect ways to do JavaScript, like without types, without like static typing and all. We're happy in that like fluffy world. But people actually do things about that. They have bindings. You can write some Chrome extension all in Go. And then you build that in a Chrome extension because you have all the API that's wrapped into idiomatic Go. And also you have those isomorphic libraries that you can use, and they'll be compiled as a target. If you set Go OS equals JS, it'll just compile for your browser. And if you switch to ARM or Windows or whatever thing, well, it'll also work on your platform. How cool, right? And this framework here uses that. The promises, the wrapper, and all that. And where is it? Ian. And there's those folks who ENG. Golang. Where's that? Oh man. Okay, never mind. It was a demo game. All WebGL, you see the things cropping up, and it's all Go.js. There's a bunch of things. And I know you still think that's stupid, but let me show you something. Recently was dropped in the next browsers, like a plan. There's a community group, the W3C, building WebAssembly. And the goal of that is to have natively in browser a language, a binary format, so that like other languages can become a compiled target for the browser. So that's on the suite of AST.js, right? ASM.js. So this is WASM, WASM.js. So it's not far-fetched to think that eventually we'll be able to code all Go. And there's some examples of like you have a server written in Go, and the client is also written in Go. And you have communication with RPC, which is the same library that you use in Go. And we're getting there. It's cool, right? Yes. Is it cool? Yeah. Isn't it cool? OK, cool. Now we're going to, so that ends it for JavaScript. Is there any questions? Yes. Sorry? There's a catch? OK. What do you mean, the try-catch exceptions? No, just catch. Oh yeah, so okay. So you're asking if the auto script that you compile has a cache for the interpreted. Yeah, as I said, there's a script object. So you can call, instead of VM run, it's VM like compile, takes your code and gives you a script object. And then you can run that faster rather than interpreting the JavaScript each time. That can be done. So it's sort of a cache. That answer the question? Anyone else? I had another hand. Yeah. No, I don't know. I don't think so. No, the goal is eventually to be able to compile it down to a binary format like that. But right now, have you seen? This is all pure JavaScript, simply JavaScript. Much about ASM.js, so I couldn't really be 100% sure, but I haven't seen ASM.js in there. But I don't know about it, so trust me. Yes. Sorry, just behind. Yeah, so ask him afterwards. Yeah, ask that guy. He says you'll be able to do that. Any other question? Yeah? Can you remove the dead code? Dead code, as you've seen, it's pretty optimal, right? It removes all the things that you're not using. So I saw the program 80K written in Go that runs on the browser. Pretty cool, right? Yeah, so you take a look later on. I'm going to now switch to the Python part, okay? And with Python, we're going to go use GoP. And GoP generates for you a CPython extension from a Go package. So then again, takes your things, does a little wrapping, like takes your comments for your commands, your functions, and then makes them a CPython thing, right? Yeah, it's pretty cool. I heard some people say, I still do Python sometime, but now you have an opportunity. OK, I do Python sometime too. So we're going to install it here. Let me switch back. I think I need this one here. Go get github.com, go Python, right? And we want that. This also brings you a little binary usage. Wow. And then you can take your code and compile it to some statically linked executable. No, it's not statically linked. I mean the compiled executable. OK, the compiled library, a .so. Let's try that. We're going to do that in ext, and we'll call that user. OK? And here, so we can go in ext. We'll have an extension here. There's nothing. And we'll make that package an ext. That's the name of the extension I chose. OK, ext. And we'll make it a type here. Simple username, a full name, and then what, a password or something. OK? And what we can do is run bind. It's working. Some work. And then, who knows Python? Raise your hand. OK, what you're going to see is the Python shell. Don't be scared. It can be simpler because there's warnings. I didn't get rid of them, so the important part is here. Like I can import ext, and that loads the ext file here, right? Which is 3 megabytes. Because then again, it has the Go runtime, the threads management, Go routines, whatever, you know, all the Go runtime. And what we could do is say ext, what's in there, user, right, full name, hello, full name, password. That's pretty slick, isn't it? So read write. OK, now let's make something interesting because we have Go, right? So we'll do something powerful. So let's create a set password and use like tremendous cryptography that we have in Go. So we're going to create a method called set password with the input here. And we will set the password by going through an algorithm. And I've chosen a very elegant algorithm. OK, so this is the implementation in Go. It's fully secure. And so I just pasted it here. Great. And we're going to, for each character, take the input and set over there. OK? And what I love of that thing, let's try that again. Bind. Sorry. OK, it's working. Is that you can say, let's say, user, full name, hello. Store that here. And then set, well, so there's nothing in the password right now. Set password, like a heavy cat. Look, cat maps to PNG. That's what I like about that algorithm, right? So that's already pretty slick. But you know, Python has that already. Heavy cat puppy or something. I don't know. And then you could say rot13. And there's even an alias for rot_13. But so you'll say, like, we don't need Go for that. And actually, you'd be right. You don't need Go for rot13. But let's consider this. Right? We're going to define a new function that we're going to spin in different threads, which is going to compute heavy cat puppy. A few times. Right? And then the start new thread takes the second parameter, which is the parameters are going to pass to the thing. Can you read that? Can everyone read that? It's a little bit low, huh? Is that better? You behind? Of course it's okay for them. Can you read that? Okay, let's open it. Let's just hear my X-top. This is a view of my CPUs, how they're working. Now they're doing video encoding, so like, let's say 10, 16% being used. And I'm going to start a few of those threads. Now can you see that? It's ramping up. Test flow, that's the executor here. That's my Python binary. So I'm taking a lot of resources, but you know, I would expect it more. Welcome to the guild, right? This is a feature. In Python, there's a global interpreter lock, which means you cannot be interpreting code on 2 different cores. You can't be interpreting Python code on 2 different cores. So that limits severely what you can do in terms of concurrency. Otherwise, you do multiprocessing, communication between them, and all that. But in Go, we do have awesome concurrency and all those channels and communication. So let's try to fit that in. I'm going to kill that one. So these are going to die. And I'm going to create another file, maximus.go. OK? So still in that package. And I'm going to call that max out resources. And you know, we're going to return a function to give control to the caller to tell us when to stop. OK? So what I want to do here is create a channel that, an empty channel. I just want to consider this closedness. This is the shortest channel you can have. It's 0 bytes. And then we're going to define a little function here that does things and launch, I don't know, 4 times that and return a function that will close the done channel. Does that make sense to everyone? So we're creating a channel. We're going to run some things in the wild. And in there, we will exit that function when the channel is closed. So to do that, we can do a select block. And when the channel is done, we can print, OK, we're done. OK, and return. And if we want to put that in a for loop, so that we go in there endlessly. And just before that, we'll do heavy computation. OK, so let's do that. Heavy computation. And we're going to start with input. I'm a cat. And then we're going to go. Does that make sense? Well, that's only once, though. We'll make it. OK? What about that? So we'll do a couple of iterations. We're looping through it, do heavy computations, and then we're checking if anyone has asked us to close. We'll do that on four different Go routines and see how that goes. Any issues with that? You think it'll work? Let's try it out. Well, have we called that? No, not yet. So we're going to go bind. It works. Working. Import in and whew, it's callable. Okay, are we ready? So 14% CPU max, 16 here. Woo! Woohoo! Now, probably the video is stuttering. And there's a little function here I should have assigned here, the little f. If I call it, bam. I'm tapping into the great concurrency. And then let's add a little thing here, because that's very important. Running hundreds of, yeah, and we close it. That's what you get with ROT13 10,000 times. Powerful encryption. And now it's done, right? So you can go up from Python Go and tap in to the Go's concurrency. What happens, you have the full-blown Go routines management, threads management in the same Python process. Who finds that cool? Yeah, you got it. You don't find that cool. How impressive. Is there any questions? Are there any questions? Yes. Is what? Yeah, so we encrypt main things with that. Yeah, it's an encryption method, of course. Okay, so that, oh yes, go ahead. Yes, under the hood, it does that, and there's actually a little, you could see the code that it creates underneath, like output directory for the bindings, and you could do that for Python 2, Python 3. And also you have a little dynamic. They provide a little script, go.py, and then you can dynamically, it's going to build it, and then you can load it directly. Or you could do as we did, we precompile and then load the .so file, which will work on all platforms. So that is it for me. Thank you very much. Now we're going to switch